Okay, so good afternoon, everybody. My name is Tracy Miranda, and this is Jonah Graham, who will be running the demo for us. And today we're talking about integrating Java and Python in Eclipse. So I know everybody here is big Eclipse and Java fans. Anyone loves Python? Uses Python a lot? Yeah, see if you're not. And I think that's pretty consistent. We work as Eclipse consultants, and in the last 5 years, we're just seeing Python being adopted everywhere. And it's not just programmers, but what I call the sort of non-traditional programmers, who are the scientists, the academics, the researchers. And it's because Python is super easy to use, it's super accessible for learning resources, and it's super powerful with the libraries like numpy and scipy. And a couple of other things I've seen as well, if you go to the conferences, is the IPython notebook. Anyone used IPython notebook? Is a fan of it? Yeah, it really allows for collaborative work and sharing your work. So that's really helped sort of push things along. And there's a great community as well. I mean, not as good as Eclipse community, but Python has a really nice community. So Java and Python, I think they're quite different beasts. So Java on the one hand, statically typed, Python dynamically typed. Java is quite verbose and Python is quite concise, which is why Python gets used quite easily for beginners. But on the other hand, Java scales really well. So it tends to be used a lot by tool developers and enterprise, and for big frameworks, well, like Eclipse and workbenches. And each one has its own sort of sweet spot of what it's really good for. So I think it's important to keep each one for where the right place is, but have them working together. And so what we've been trying to do is get that Java and Python over the last 4 or 5 years just working in harmony. They might be different, but they're similar in other ways as well. So specifically, we'll talk about work we did with Diamond Light Source. And Diamond is a synchrotron in the Oxfordshire countryside. They welcome researchers, academics, scientists who come and they study their samples, whether they're retinas for eyes, dinosaur bones, chocolate, whatever you have. They capture the data there and then they analyze it in Dawnsci, which is a plotting workbench. And Dawn is aiming, it's an Eclipse RCP workbench, and the aim is to collect all these fragmented tools, many of which are Python-based, and put them all in one environment. And trying to get the scientists to move over, but in some ways knowing that some scientists are always going to use Python, and so they need an environment where they can sort of switch between both and use the best of both worlds. So we'll be talking about all the things we did to create that environment, and sort of shortcutting to the lessons learned, or how we would recommend if you are a tool developer who wants to provide a rich Python environment in your Eclipse framework, how you might go about doing that today. Okay, so the requirements were that, first of all, they wanted to be able to control the use of interface, or control Eclipse from Python, from a Python console. Then there was moving data around. So they wanted to be able to move from Python to Java. So in Python, you're able to access Java, or in this case, Eclipse. And for Diamond's case specifically, they wanted to be able to plot things, so plot arrays from Python in the workbench. So when they wanted to visualize their data, it's no good looking in a console, but having that nice and graphic. And of course, while still being able to run all your existing scripts. And then on the other side, this was a later requirement that came along of being able to, in Java, access Python code. And the cases here were things like workflows, where you might call out to a Python algorithm, and or things like they had like function fitting, and they thought, well, is there a way we could have a scientist write a new function fitting algorithm, or maybe a color scheme, and do that in Python, a language they're really comfortable with, but have that fully integrated with Eclipse and Java. So where to begin? So the first step is integrate Pydev. So anyone familiar with Pydev? Yeah, seeing if you know. So Pydev are the Eclipse plugins for Python development. It's a really good project led by Fabio Zadrozny, and it's really mature and it's very, very feature rich. So Python provides an Eclipse-rich environment for CPython, Jython, PyPy, which is Python written in Python, IronPython, and Cython. And you get your standard Eclipse goodies, just the editor features and the interactive code completion. And the other part of Python that's really, or rather Pydev, that's really powerful is the debug. So it's got a really, debug is hard, and it's got a really good debug core. And it's got some really nice features, like you can look at variables, and then you can right-click on a variable, which is an array, and you could say, plot that as an image, because looking at numbers doesn't mean anything to me. But if I plot it, I can tell, has my data been corrupted? And there's other features. Has anyone used PyCharm? A couple. Well, PyCharm actually uses the Pydev debugger backend as part of it, because it's all open source. So they've kind of taken that and wrapped up PyCharm around it. So yeah, it's really good, really powerful. I could talk all day about Pydev, but I'll move on. Okay, so the other bit that people might not know about is that there's a lot of integration with Pydev. So you can set up different GUI event libraries and then have things called from Python. And actually, can we do a quick demo of maybe just calling some matplotlib from Python console?
I have a Python console down at the bottom right, so it's a static console. So we did work to try to make IPython in the transition, especially from IPython users, into the IDE nice and clean. So we wanted it to look and feel like IPython does. And one of those places is making Pylab work really well. So I'll just set up the Pylab environment using WX. And the key thing here is that we're going to have an interactive GUI running at the same time as an interactive console. That's a great feature of IPython, and it's not available when you use Python by itself standard. So we'll create a bit of a data set. It's just some random data, about 10,000 points, and we'll plot a histogram of that. And it's back here, so we have a histogram. So this is an interactive view, and over the console, it's still an active console. So that's a really nice feature. There's a whole bunch of other IPython features. If you are familiar with IPython already, it should make the transition into here a little bit easier.
Yeah, so the idea was you tell the scientists, well, you can use your existing tools, and then you try to get them then using more of the integrated features of the plotting eventually. Okay, so if you integrate Pydev, the next thing people would typically do is just use Jython, which is the Java implementation of Python. And that runs in the JVM, so it gives you access to all your Java objects. So it's really nice for scripting things in Eclipse or in Java. But on the downside, what places like Diamond would find is that people could do that in Jython, but then they'd say, well, I can't run my existing script because my script uses numpy or uses scipy, and those are C modules. They're actually written in C. And the Java implementation of Python Jython does not support C modules. So there's talk of a technology called Dawnsci, which should solve this, but there's no solution today. So that doesn't quite work. And one of the things as well, from a usability standpoint, in Pydev, you get asked when you want your console, do you want to be Python or do you want to be Jython? And if you're in Jython, then you're like in this separate environment. You can't necessarily do IPython functionality. So it wasn't ideal for users to sort of be in this little sandbox. So Jython will get you some way to accessing, connecting Python and Java, but it's kind of limited. Okay, so from there, we looked at this technology called Py4J, which, if you go to the website, they build themselves as a bridge between Java and Python. And Py4J was really good because it runs in the JVM and it allows Python to access the Java classes. But unlike Jython, you're now doing this in Python, so you can stay in the one environment. So you can continue to run your scripts, which have scipy and numpy, and it gives you control of the user interface. It doesn't fully get you all the way there, so it creates proxies rather than moving data. and it kind of exposes everything. So if you want to see anything in Java, you see everything, which sometimes can be a bit of a usability issue for users if you want to sort of focus them on a few bits of the API. And there's no real Java to Python support. But Py4J was really good, and one of the things we did quite recently was support a way that you could do interactive autocompletion. So not only could you access the Java, but you could get all the autocompletion in the Python console. So if someone was accessing Java code, they'd get Eclipse-like completion and help. And maybe Jython can show a bit of that in action.
So what I'm going to do is I'm going to plot a little tiny bit of data down here at the bottom. So I just put a little bit of data, and it's just a random 10,000 pixel picture. But once I have that there, I can get a handle to a Java object. And this Java object, we call it the plotting system, and it allows me to manipulate all the Java. So it is the thing that represents in Java all this stuff. And if we look at this plotting system in Python, its representation is it's a Java object. That's the type of it. And then with that, we can do some autocompletion, and we can get all the methods. So it's using reflection to get all the methods from Java and tell Python to populate all this information. And if we go off and get a trace, we'll get the first trace in there. And trace is just the handle to the thing that's being drawn. Now, trace is another Java object. You see it's got a new ID. It's because the ID is how the proxy knows how to connect it back up in the JVM. And then we can do things like we can change the palette. So we can call methods on it. So we can make an NCD coloring. If you're into your palettes, there's some exciting stuff here. Probably most people in this room haven't really had to do color palettes. So yeah, that's using Py4J.
And one of the really nice things with even just setting the color maps, it was important for the scientists to be able to present the data in a reproducible way, so they could attach a script to someone else and have them set exactly the same color map, set the right resolution, and set everything up in a very, very reproducible way. So that was quite a nice thing to do. And Diamond also used Py4J to record macros, so when people do different operations, they'll record them so they can save what they've done and sort of script that later. Okay, so that gets you a bit further, but we still cared about moving data around. And there really wasn't anything that existed that we found that was useful. So Jonah implemented a custom solution that would work for moving the data around, and that's what we call AnalysisRPC. And RPC meaning remote procedure calls. So it's like an enhanced remote procedure call where it specifically understands the type of data we're dealing with, in this case, data sets or for numpy ND arrays, and things like regions of interest, which might be boxes or circles highlighting a bit of the data, and exceptions, which are Java and Python exceptions. So it has this knowledge of these types, and that's the important bit because it understands, it knows about these types, it knows how to pass them and what to do with them. And the original implementation was done, language independently. So the idea was that you could extend it to any language. It didn't have to be Python, it didn't have to be Java. But initially the server and client were written for Java and Python. So this tries to show what's going on. So let's say you want to take some data from Python, and I'll walk you through it. Take some data from Python and have that plotted in Eclipse, so you can visually look at it. So start with that. Over here you've got one array, which is the x1, and a y1, which are your numpy ND arrays. And you've got a client set up, and you'll then call plotter and send your x and your y data. It goes through a process which we refer to as flattening, which gets it ready to go into the transport mechanism. So in this case, the transport has two parts, which is the XML RPC, which is standard XML remote procedure call, and disk and memory. So on the XML RPC side, we use that to transport the meta and the simple data. So it would be too expensive for full arrays, but the simple data gets moved through there. And then the data sets get copied, and in this case, it's done on disk or memory. And on the other side, on the Java world, it's unflattened, and then defines the references. So you have the code that looks like that, where you've got a plotter and then your line. And likewise, if there was a return value from the Java, that would get flattened, pass through the transport layer, and come out in Python. And the idea is that you could have different implementations on either end. But I think what's better is that we see it in action and see what sort of things it allows us to do.
So back over here, I was actually using a bit of AnalysisRPC a second ago. Let me just start a nice clean environment here. Make a few things disappear, do that magically. Okay, so similar to before, I can create a bit of data. I can plot that data. Now, what I did over here, I have this data variable here. That is a 10,000 entry thing, so that's 80,000 bytes. Still fairly small, but if we had to serialize that in a non-efficient form, there would be an overhead. We can scale up to a pretty good size before even our way slows down in any noticeable way. And then we've passed on here. So this is the Python entry point, and inside there it's going to go and start the RPC client and connect up to the server, do the XML RPC call, and all the data is going to go there. It's a synchronous call, so it's going to wait for all the plotting to be done and then return back to the prompt. We can do some other ones. So here's an XY graph of a sine wave. So that looks fairly interesting, I think.
So I'm going to add that Jonah uses F2, which is a Pydev shortcut. So it just takes the line from the editor and pastes it in the console. So works really nicely for demos.
So and the ability to connect up to make the console a bit easier to use. We can grab some data. So I have a file I opened here earlier, which is just some data that was collected from an experiment. And I can drag that data down into here, and it's going to convert it into the, bigger so you can see it. So it's going to convert it into the magic Python that knows how to load it. And so first we see the file name, and at the end we say the specific part of the file that we're interested in. So if we do that, we're loading the file up, store that in a variable. Now what we can do with that is, all right, so this data needs to be squeezed. It might mean anyone who's in NumPy might know what that means, but I'm just going to squeeze it manually because there's some extra one entry dimensions anyway. What we have now is data which is a 512 byte by 512 byte array, which we want to plot or do something else with. And then right now I'll do something else quickly. Because this interactive console is connected up to the normal Eclipse debug features, I can now access that data here, and I can right-click on it, and I can plot it, and I can do other things with that. So now I've plotted that data, and it's appeared over here, and I forgot to fully clean it up, so I'll just get rid of that green bit. And now you can see the data. It's got some really, really important bright bits here, and that was the sample. That was the thing that the scientist was trying to analyze. So now we've seen data going to Java. Now, the flow the user might have is they're going to have this file that they're manipulating in Python. They plot a little bit of it. Then they want to do is identify some interesting thing about that, take that back to Python, do more analysis, and then that's their run debug cycle, their edit debug cycle. So I'll do a little bit of that now. What I'm going to do is I'm going to say, well, that white bit is the interesting bit. I don't really care about the rest. So I will just make this a bit bigger so you can actually see what's going on. So that white bit had a bunch of dots in it. And what we've done here is we've got a profile across the x-axis and across the y-axis. And It's a bit hard to see on the screen, but if you zoom in a little bit, you should be able to see a little bit what's going on. So across the x-axis in the blue, you see that there's two brighter areas and one kind of medium bright area if you sample all of that. That's that blue line. If you do the same thing across the y-axis, you get that red line because there's a spike there, a spike there, and a spike there. But I really just care about having that middle bit of data. So I'm just going to shrink this down until I get rid of the stuff I don't care about. Now I've identified, scientists have identified a useful piece of data which they want to do something else with. But they want to do it back in Python. And they want to know, well, where are those coordinates? How do I get it automatically into Python without having to futz around too much? So we call another function. And this one has a return value. So the data is having to be flattened on the Python on the Java side, sent across, and coming back on the Python side. And if we look at this, unlike earlier when we were seeing Java objects, we actually have something which is a rectangle. And over here we've got some coordinates of them and stuff. So what the user might do is they might select a little bit of the data. That was a little bit of magic, I know I didn't go into it, but what we now have is we now have a little bit of data, and instead of being the 512 by 512 we had before, and now it's just the 28 by 52 pixels we really cared about. From here, we can go off and run even more analysis. Is there anything else you want me to know?
No, that's
okay,
good.
So
Yeah.
that's the full round trip of Java and Python with actual data.
So, sorry, maybe I missed that, but how do you know about the objects that are available in Java?
So, no, I didn't really introduce that properly, but this DNP package is a package which is basically the main entry point for users who are using this tool. And so everything's available through there. And DNP stands for Dynamo NumPy. So it's everything in NumPy plus is imported there. So everything that NumPy has is there. And then there's some extra things. One of them is plot. So that's access to all the plotting functionality within the dot workbench. And then so all the methods within there are how to get and set data in the plotting side. And similarly, there's an I/O submodule to access all the I/O functionality.
So you can't reverse engineer any sort of like random Java code.
With AnalysisRPC, no, because the RPC server in the actual implementation has to expose what's allowed to be done. And what we're exposing here is plotting. So it says these are all the methods, and there's a big Java file somewhere which has all of the Java methods that are exposed through this method. So Py4J is the way we fall back to say, well, actually, I really know what I'm doing, and I'm going to start calling Java methods. And Py4J exposes the entirety of the JVM, which is really good if you're in a hole, and it's really bad for most users because, for starters, well, you can kind of do things that you probably don't want to do, and you can start calling things on that should be called in UE threads or do other things like that you don't really want to do. So this provides a clean API to the Python console. So, okay.
Okay, that was the demo. And yeah, likewise, you can do the reverse. And this was just trying to capture the idea that within Java, you might want to send something across to Python and have call your algorithm, and it's the same idea. You flatten, pass on the metadata and the data sets, and then gets unflattened at the other end. And where that was used in Dawn was in workflow. They have this workflows where you, a bit like MATLAB Simulink, where you have different, what they call actors, and you could have a specific Python actor which would connect it up so that you could then call into your Python code. Yes, so AnalysisRPC gave us what we wanted in terms of moving the data around efficiently, and it had both Java to Python and Python to Java. It had a generic calling infrastructure, which made it was really nice from a usability point of view, because it didn't matter whether you were calling something remotely in Python or in Java. It was a clean API, and it had a way of handling exceptions. So if something went wrong, you'd at least get some handle on being able to figure out, was there an exception in Python when you call something from Java, or vice versa. Now, on the downside, it only exists in Dawnsci today, and it's quite tied to their data types. So we'd like to repackage that and make it available more widely, and also look into, well, can we make it more generic so that you could put your own custom data types on it, so it's not just perhaps for science, but it might be for embedded or other applications. Right, so kind of in conclusion, you can really do some powerful things with Java and Python integration. It is possible thanks to quite a mix of different technologies. So you've got Pydev, you've got Jython, AnalysisRPC, Py4J, and sort of going forward, we ask ourselves, well, is there a way to unify all these, or at least have them work well together? So if someone else is coming along trying to do something like this, it's pretty straightforward what things they need to do and how they can configure things. So that's one of the things that's an ongoing initiative as part of the science working group, which is under Eclipse, and it's been going for about a year. And as part of that, we're sort of looking for a home for AnalysisRPC to make it more readily available for the other projects in the science world. And today it's part of Dawn, considering somewhere like Eclipse2 or even a science top-level project. But in the meantime, we're doing a bit of a requirements capture. So it's using Dawnsci. There's ICE from Oak Ridge National Labs, Passerelle, Workflow, Airbus, and the folks at Trace Compass have also got a couple of uses for it. So if you're doing something in a similar space, let us know your requirements so we can kind of tailor that and just make it much more of a reusable infrastructure. That's one of the tools that you get as part of Eclipse. And yeah, that's it. So we'll take any questions, or if you want to see anything else. Yeah?
So is Dawn an open source project at Eclipse.org?
It is. It migrated recently, so some parts of it are under the Eclipse umbrella and other parts are moving there. So yeah,
Okay.
you can.
Yeah, it's in incubation still, so because you'll find the source code on GitHub still not at Eclipse.org.
Yes, all the.
Matters yet.
Yeah, it's all open source. Some on Eclipse, some just go directly to Dawn to get it. So yeah, have a look. Anything else? Okay, great. Thank you very much.